Hello, guys. Welcome to Ramta Solutions. Welcome to your grade 12 Pronunciation Calculus exam prep series. Today, our examination comes from the Free State. This is the Maths paper 1 of June that was written in 2024. So, by the way, let's thank SA Exam Papers for their library of past papers, okay? Now, this is a past paper, guys. Before we proceed, we have to read instructions, all right? This is to assist you guys so you know how to tackle your exams. It's important to read all your instructions. We are not going to read all of them. We're going to choose just a few. For example, instruction 3, clearly show all calculations, diagrams, graphs, etc., which you have used in determining your answers. And then instruction number 5, if necessary, round off answers to 2 decimal places unless stated otherwise. With this, in the middle of your calculations, if you have decimals, do not round off to 2 decimal places. In the middle of your calculations, maybe round off to about 4 or 5 decimal places, and only the final answer should be rounded off to 2 decimal places. And then they also tell you that a diagram sheet is attached at the end of the question paper. You will see it, but I'm not going to use it. And of course, instruction 7, diagrams are not necessarily drawn to scale. Instruction 8, write neatly and legibly. That's important. Write neatly and legibly. Yes, you want your distinctions, but also work on your beautiful or good presentation of your work. Okay? Instruction number 9, answers only will not necessarily be awarded full marks. Sometimes show how you got your answers. So make sure that you show everything that you did to come to the solutions that you have, okay? Or to come to the answers that you have. Okay. So our exam, or rather our topic, is normally question 6. So we're gonna go to question 8. So we're gonna go to question 8. Indeed, it is question 8. So let's see. So this is question 8. All right, this is question 8. Let's see. 8.1. Remember, guys, 1 mark, 1 minute. So make sure that you spend, for this question, you need to spend about 14 minutes. So for the purposes of this video, we must be done at about 17 minutes. Let's go. 8.1, given, f of x is equal to x squared minus 3. Use first principles to find f prime x. So f of x is x squared minus 3. We need to find f of x plus h, meaning where there's x, you put x plus h. Okay? Let's go. This will be x squared plus 2xh plus h squared minus 3. This formula is given in your information sheet. Here is it. Do you see it? So I advise that you know them off by heart. Okay? But otherwise, you can go to your formula sheet. Okay, let's go. So f prime x is equal to the limit as h tends to 0 of f of x plus h minus f of x all over h. This is equal to the limit as h tends to 0 of, what is f of x plus h? It is x squared plus 2xh plus h squared minus 3 minus, what is f of x? X squared minus 3 and all over h. At this point, we cannot substitute the value of h to be 0, because if we do, we will be dividing by 0, which will be invalid. So let's proceed by trying to simplify this expression. So we see x squared minus 3 minus 3. So we are left with 2xh plus h squared all over h. Even at this point, we should not substitute the value of h to be 0. We must simplify. So here, I do see that we need to factorize. So we will say h as a common factor. We are left with 2x plus h all over h. Now we can see the h's are cancelling. All right, the h's are cancelling. We are left with 2x plus h. Now we can substitute the value of h. When we do, we drop the limit. So we have 2x plus 0. What is our answer? Our answer is simply 2x. By the way, this is what you could have determined using differentiation rules. But the question said use first principles. So without a doubt, your answer is correct. Okay, moving on. 8.2, determine dy dx if y equals 9x to the 4 minus 6 all over 3x. What you need to do here, you need to divide every term of this equation or of this numerator by 3x. So 9x to the 4 divided by 3x will be 3x to the 3. And then 6 divided by negative 3x will be 2 over x, but because we're saying over x, we can write it as 2x to the minus 1. Okay? It's okay like this. Now, you have simplified this. You can now find your dy dx. That is, you can now differentiate. So this becomes 3 times 3 will be 9. 3 minus 1 is 2. 2 times negative 1 is positive 2. Minus 1 is minus 2. This is your answer. Okay, good. 8.3. Let's see. Evaluate leaving your answer in a third form. Did you hear this? Leaving your answer in a third form. So let's see. D dx of cube root of x cubed minus 2x times square root of x all over 3x. So let's try to simplify the numerator first. D dx of, so here cube root of x cubed is similar to saying x minus 2x times x to the half all over 3x. Okay, we're not yet done. So x minus, when bases are the same, you add exponents. We have 3 over 2. 1 plus half is 3 over 2 all over 3x, isn't it? Good. So there are those that are questioning how did we say cube root of x cubed is x. This is because this becomes, cube root means power 1 over 3, right? So obviously this is x. Happy? All right. Now let's try to simplify this again further. And we'll say x over 3 over 3x. X over 3x is the same as 1 over 3 minus 2x to the power 3 over 2 over 3x is the same as 2 over 3. Now 3 over 2 minus 1 is the same as half. Okay, is the same as half. Let's confirm. 3 over 2 minus 1. Yeah, it's fine. Okay, now we can differentiate. Okay, now we can differentiate. So we drop the d dx. Okay, so the constant, it will be 0. And this will be 2 over 3. The power there is half. And then what is half minus 1? It will be minus half, isn't it? So this is therefore 1 over 3 x to the minus half. However, the question said leave your answer in a seed form. So our answer is minus 1 over 3 square root of x. This is your answer. Okay, this is your answer. Okay, it said leave your answer in a seed form. So this is your answer. Okay, this is your answer. If you're wondering, it's because we say minus 1 over 3x to the half. And obviously power half is a square root. Okay, good. So this is your answer. Okay, now let's go to 8.4. 8.4. Remember, we should be done with this question at about the 17th minute of this video. All right, but otherwise in 14 minutes. That was our 14 minutes. So let's see. 8.4, given f of x is equal to x cubed minus 2x plus 1, and the gradient of the tangent at the point of contact is 3. Determine the x coordinate or coordinates of the point of contact. They said tangent, so it must be 1x coordinate. Don't be fooled by this ordinates or coordinates. It should be 1, so don't worry. So here they're saying the gradient is 3. So this means f prime 3, f prime x, guys, must be equal to 3. Okay, this is what it means. So what is f prime x? F prime x is 3x squared minus 2 equals 3. Okay, so what is this? 3x squared equals 5. X squared equals 5 over 3. Therefore, x equals plus minus square root of 5 over 3. Okay, x equals square root of, x equals plus minus square root of 5 over 3. So these are the values of x. Okay, these are the values of x. Okay, the x coordinates of x. Okay, hence it makes sense why they said x coordinate or coordinates. It's because they can be two, one. So yeah, it's fine like that, right? It's fine like that. But I can assure you guys, that it's supposed to be 1. It's supposed to be 1 because the gradient is a positive 1. If you look at your graph, it will be, let's say, something like this. So for the gradient to be 3, it means your tangent must be something like this, because if it's negative 3, it will be like this. So we should be taking only 1x value. But because of this, it won't really matter. Okay, so but it's fine. So this is it. Okay, all right. So otherwise, this is it. Even if you take the positive value, it's okay. All right, cool stuff. Oh no, I'm lying. This is a cubic graph, right? This is a cubic graph, so I guess it makes sense because it's a cubic graph. Okay, cool. All right, so we are done. We were able to finish this in 13 minutes and some seconds. That means we saved about 4 minutes, isn't it? We saved about 4 minutes. So it means we are on the right track. Okay, now let's go to question 9. So question 9 says a cubic has the equation f of x equals negative x cubed plus 5x squared minus 7x plus 3. Determine the coordinates of the y-intercept. Remember, the y-intercept is the constant. So when you look at it here, the constant is positive 3. So this is 0, 3. 9.1.2, determine the x-intercept. So with the x-intercept, we'll say f of x must be 0. What does it mean? Minus x squared, x cubed, buddy, minus x cubed plus 5x squared minus 7x plus 3 must be equal to 0, isn't it? So let me just divide by negative a. X cubed minus 5x squared plus 7x minus 3 equals 0. any value of x that will make this 0. Let me try 1. Okay, 1 this. So when x is 1, this will become 0. So I will try x, because x equals 1 will be 0. I will try, this is now x minus 1. Okay, now x cubed divided by x will be, and we do this, x squared minus leave space x minus leave space close equals 0. X cubed divided by x will be x squared. Cool, we done. Now negative 3 divided by negative 1 will be positive 3. So this will be positive 3. So we need the middle term to be negative 5. So let's see. Negative 1 times x squared will be negative x squared. So here negative times whatever, x times negative something x, it will be x squared. So we need this to be, if this is minus x squared, this must be 4x, because when you look at this times this will be negative x squared, this times this will be negative 4x. Them combined will be negative 5. Therefore we are good. So this is x minus 1. Further factorization, it will be x minus 3 and x minus 1 equals 0. So x equals 1 or x equals 3, isn't it? Even if you write this twice, it's okay, but I don't see the need of writing it twice. Okay, I don't see the need of writing it twice, but maybe let me just write it twice. Okay, so this is it. So these are our x-intercepts. If you like, you can say this is 1 and 0 and 3 and 0. Okay, perfect. So by the way, this question, how many marks is it? It's long, eh? It's 32 marks. Imagine, guys, it's 32 marks. So we must be done in like 35 minutes of this video. So let's see. Interesting. All right, let's go. Okay, 9.1.3. 9.1.3, determine the coordinates of the turning point. So we need the first derivative. So the first derivative of f of x will be negative 3x squared plus 10x minus 7. We need to equate it to 0, right? Good. And this becomes negative 3x squared plus 10x minus 7. If you like, you can say it's minus 10x plus 7 equals 0. Then we can say this is, I'm going to say 3x minus 7 and then x minus 1. This will work, isn't it? This will work. So what is this? When I look at this, I see that x equals 7 or x equals 1. Not just 7, sorry, 7 over 3. Now remember, guys, this question was saying coordinates of the turning point. It wasn't saying x values of the turning point. So I now need f of 7 over 3. Let's see, what is it? Minus 7 over 3 cube plus 5 into 7 over 3 squared minus 7 into 7 over 3 plus 3. Let's take out our calculators quickly. Minus open bracket 7 over 3. Oops, my God. 7 over 3 plus 5 into 7 over 3 square minus 7 into 7 over 3 over then plus 3. What do we get? I got 32 over 27. Right? I got 32 over 27. Now f of 1, I will not hesitate. It is 0. I remember saying to you, when we put x equals 1, we will get 0. Here is it. Do you see it? So the coordinates of the turning points are, therefore, turning points are 7 over 3, 7 over 3, and 32 over 27, and 1 and 0. Okay, let me charge quickly, guys. Okay, so these are our turning points. All right, these are our turning points. So we are good to proceed. Now they say, I don't like this 9.1.4, but it's okay. 9.1.4, they say sketch the graph of f. Okay. Me sketching it. Let me see what I should do now. Okay, I will try minus 2 would do. Yeah, let me take it a bit down. -2, -1, 0, 1, 2, 3, 4, 5. This is the value of x. And then 1, 2, 3, 4. And then this is 1, 2, 3, 4. 5. So let's see. We had x-intercept at 1 and 0 and turning point as well. So this ends with a frowning face. And then we had another turning point at 7 over 3 is 7 over 3. What is it, guys? It's 2,33, isn't it? Yeah, it's 2,33. Let me confirm. 7 over 3 is 2,33. And then what is the y-intercept? 32 over 27. 32 over 27. It's 1,8. Okay. 2,33. 2,33. Let's say it's here. And then y value is 1,18. Let's say it's somewhere here. So it's fine to put it here. And then what was the other x-intercept? The other x-intercept was 3 and 0. So it was 3 and 0. So this was ending with a frowning face. It was ending with a frowning face. Okay, cool. And then our y-intercept was 3. So it was here. So now how we plot it will be like this. Okay, it'll be like this. This is you plotting. So this is you now plotting your f of x. Okay, so this is your f of x. Okay, this is your f of x. All right, cool. 9.1.5, let's see now. 9.1.5, determine the x value of the point of inflection. 9.1.5, x value of the point of inflection. It's up to you. You can say first derivative of x equal 0. What is it? Or you can say the midpoint, minus 6x plus 10. So it is minus 6x plus 10 equals 0. So minus 6x equals minus 10. So x equals 5 over 3, isn't it? That is 5 over 3, isn't it? That is 5 over 3. So you can use second derivative or you can use midpoint of the x values of the turning points. Right? Cool. 9.1.6. 9.1.6. Sketch the graph of f double prime of x on the same set of axes. Cool. This graph is oh my. This graph is, as you can see, negative 6x plus 10. Oops, messed it up. Negative 6x plus 10. So, and then what is its x-intercept? Its x-intercept is at 5 over 3. 5 over 3 is 1 comma. What is 5 over 3? must be 2 over 3, 5 over 3, 1,67. So its x-intercept is 1,67. Let me just draw it here. It's somewhere here. 1,67. It's somewhere here. So where it'll be, I don't know where 10 is. So let me just say 10. So I didn't draw this to scale. So that is our mistake. But you should have drawn it until to 10. Okay. So this is it. Okay. This is it. As you can see, this graph here, it has a negative slope. So it is not surprising that it looks like this. This is your second derivative, right? Cool. Now, moving on, 9.1.7, 9.1.7, 9.1.7 says, let's see, write down the value or values of x for which the graph of f is concave up. Remember, for it to be concave up, it's here. This is when it is smiling. So it is smiling to the right. It is smiling to the left of your point of inflection. All right, to the left. So this is when x is less than 5 over 3. This is when it's concave up. Okay, it is smiling to the left of point of inflection. Happy? Great stuff. Now, let's go. 9.1.8, for which value or values of x will the first derivative times f of x be greater than 0? Ooh, this graph. Let's see. First derivative, obviously, it will be like this and like this, and the turning point will be somewhere here. You see, the turning point will be somewhere here. I don't know where it'll be moving, but it'll be something like this. Okay, it'll be something like this. So check this out. They saying, where will they be both positive or both negative? Remember, when they say greater or equal to 0, they say they can, one of them or both can be 0, or what? Or both can be positive or both can be negative. So let's see. When do we get 1 to be 0? When x is 0, let me see, y value to be 0. Okay, it's at the x-intercept, so we don't have to worry. So for them to be either 0, okay, let me look at this. I'm going to look at the intercepts, x-intercept. We want them to be both positive or both negative. Can you see to the left of this point, to the left of x equals 1, f prime x will be positive. All right, can you see that? F prime x will be negative, but f of x is positive. So this is not what we are looking for, because positive times negative is negative. We're not looking for that. Now, again, as you see, as we move from this point onwards, where x is greater than positive 1, even to positive 3, here at positive 1, both are 0. At positive 3, both are 0. Above positive 1 and below positive 3, they are both positive, which is good. Again, when you look at this below or to the right of positive 3, they are both negative. This is exactly what we are looking for. So when are they both positive or both negative? We can simply say this is when x is greater than 1. Do you guys agree? This is when x is greater than 1. So that is our answer. It's simply that. This is when x is greater or equal to 1. Okay? When x is greater or equal to 1, this is our answer. Okay? This is our answer. When x is greater or equal to 1, check this out. At x equals 1, one or both of them are 0. Greater than that, you can think of any number you can think of. When one is positive, the R is positive. When one is negative, the R is negative. So this is our answer. Okay. Right. Now let's go to the next section. 9.2. Oops. 9.2. Let's see 9.2 now. So 9.2 is very interesting. 9.2 says, there's a mistake, by the way, for this one. It should be f of x equals x cubed plus 3x minus 24 plus 30. Okay? So the graph of f of x equals x cubed plus 3x squared minus 24x plus 20 is shown below. A straight line with equation y equals 8 touches the graph of f of x at the turning point. Okay, so q at the turning point, q with coordinates 2 and minus 8. Did you guys hear that? Q has coordinates 2 and minus 8, and the graph crosses f of x at point P as shown in the diagram below. Determine the coordinates of P. Okay, determine the coordinates of P. So what we need now is this. We need to know where f of x, right? We need to know where f of x is intersecting with this graph of y equals 8. So what is f of x? It is x cubed plus 3x minus 24 minus 24x. Let me fix this. Minus 24x x squared minus 24x plus 20 equals negative 8. So this therefore is x cubed plus 3x squared minus 24x plus 28 equals 0. This, we are looking at the point of intersection. All right. So we already know one of the points of intersection here. We need to know the other. So to make this 0, let me think of an x value when x is 1. Let me see when x is 1. 1 plus 3. No, it's. Let me see. 1. No, it won't work. Minus 1 as well. It won't work. Let's think of now x equals 2. X equals to 8. X equals to 8. 12. Nah, x equals 2 is correct. So we will think of x minus 2, and then we'll say leave a space x squared minus leave a space x minus leave a space close equals 0. X cubed divided by x, it's okay, we'll leave it like this. Positive 28 divided by negative 2 will be negative 14. We need this to be positive 3x. We already have negative 2 times x squared is negative 2x squared. Negative times negative here will be, x times x will be x squared. So this is already positive 3x, or it should be positive 3x squared. But here we have negative 3x squared. So this means we must say this must be positive 5. This must be positive 5. This must be positive 5x. Okay? So further simplification, let's see. X minus 7, x minus 2 equals 0, but the bigger factor must be positive. So it'll be x plus 7. Therefore, here we have x equals 2. I'm going to write it once this time. X equals 2 or x equals negative 7. If you recall, we got q value here to be positive 2. So we are good. So it therefore means the x value of p must be negative 7. Obviously, its y value is negative 8 because it's along the straight line. Therefore, p has coordinates negative 7 and negative 8. Right? These are the 2 points where these two graphs are intersecting. Where x is equal to 2, we are sorted, it's this one. Then it means the other one must be x equals negative 7. Okay? Great. Now, 9.3 says, let's see what it says. 9.3 says the graph of the derivative of f, sorry, the graph of derivative f prime of a function f is shown. Sharp. 9.3.1, determine the x values of the turning points of the graph of f. X values of the turning points of the graph of f are the x-intercepts of the derivative. Okay, so that is x equals 1 and x equals 5. You say and or it doesn't matter. Okay, but say and. Okay, and then 9.3.2, on what intervals is f increasing, rather decreasing? So when you look at your graph of a derivative, in the negative y value, or in the negative y region, this is where the graph is decreasing. In the positive y region, this is where f will be increasing. Remember, this is when you look at the graph of a derivative to make sense of your original. For example, imagine it in this way: when a is positive, your graph is like this, isn't it? So you expect this guy to be like this. You expect him to be like this. He's smiling, right? You expect him to be like this, isn't it? You expect him to be like this. Do you see it? So when is he decreasing? Below the He's decreasing below the y region. Can you see that? Or below the x-axis. Do you see that? Indeed, this is indeed where it is decreasing. Can you see this? And look at that. Do you see it? Now, what about when it's increasing? Let's say when when a is negative, obviously it ends with a frowning face. What's happening with this one? With this one, what's going to be happening it will be like this. It'll be like this. All right? Okay, let me say this. It'll be like this. Okay? So, when is it decreasing? When is it decreasing? I said below the x-axis. Right? Below the x-axis. Do you see it? Where is below the x-axis? Here is it. Do you see it? Do you see it? This is when it's decreasing. Okay? Now let's answer the question. To answer the question, on what interval is this increasing? So this is when, if you like, you will say this is when x is greater than 0 but less than 1. Okay? This is when x is greater than 0 but less than 1. Or when x is greater than 5 but less than 6. Okay? You can leave it like this, you are good to go. Okay? You can leave it like this, you are good to go. Okay? All right. So this is it, guys. This is how you answer your questions. Okay, this is how you answer your questions. I did promise that this section, let's see, 32 marks plus 14, was supposed to be done in 46 minutes. We are done in 38. And this is how you answer differentiation calculus. Remember, if you would like to get in touch with us, visit our website www.romtasolutions.co.za. And if you want to follow us on your favorite social media platforms, the links to different social media platforms, of course, you're watching on YouTube, will be given in the description of this video. Same applies to you if you're looking for a Twitter, you can contact us on WhatsApp. So with that being said, it's a wrap and bye-bye.